Good afternoon, everyone. It's Dex here from A2K, and thanks for joining us for today's webinar, Digital Transformation in the Manufacturing Industry, How to Leverage Autodesk for Industry 4.0. Applications Engineer John will be presenting for us. So first, we just go through A2K, all about fostering innovation through consulting and training. A2K Technologies plays a vital role in helping infrastructure, building, mining, construction, architecture, and manufacturing industries reach their full potential by delivering complete technology solutions and support services such as education, consulting, and IT managed services. We're working with visionaries to shape the future of design and in turn enable them through innovation to minimize risks, improve productivities, and achieve excellence. A2K Technologies is considered the business partner of choice and trusted advisor by vendors and clients. We partner with major software and hardware vendors to meet our clients' technology needs. We strive to exceed client expectations by understanding the challenges and delivering solutions through experience and innovation. We work with clients and companies of any size nationally and abroad.
Thanks, Dexter, and good afternoon, everybody. Thanks for taking the time out of your day to join us for today's webinar. We've got an interesting subject ahead. As Dexter said, my name's John Pitcher. I'm a applications engineer with A2K, and just a couple of things about me. So I'm a certified Autodesk trainer and technical support engineer. I've got roughly 20 years industry and manufacturing experience. I started off my career as a fitter machinist and spent a number of years in various aspects of manufacturing, including hydraulics and pneumatics, CNC programming, machine tool manufacture, and a number of other aspects of general engineering. For the past 13 years, though, I've been directly involved with the CAD industry and been running training and things like that for the Autodesk suite of mechanical products. And more recently, I've been involved in the additive manufacturing side of things, or 3D printing of various components for particularly manufacturing environments. So that's just a little bit about me. So yeah, again, thanks for joining us, and hopefully what we've got to present today will be of interest and of value to you. So today we hope to cover a number of different things, and this is a slightly different webinar in the sense that we're going to be talking a little bit about Industry 4.0. I guess first up, we'll have a bit of an introduction on what Industry 4.0 is. We're going to look at some of the challenges and opportunities that will be presented by Industry 4.0 and how it's going to affect businesses of the future. We're going to look at Autodesk's cloud offerings that sort of back end into Industry 4.0 with connected systems and collaboration and things like that. So basically that's what we hope to cover today, and finally we'll go through some cloud storage, and I want to particularly talk in a bit of a live demo on Fusion 360, which is one of the Autodesk offerings of that are connected to cloud storage. So we'll spend a bit of time today working through some of the functionalities involved in Fusion 360. And finally, as Dexter said, if you've got any questions, please add them to the Q&A section in the Zoom control panel, and we'll try to answer those towards the end of the presentation. Okay, so just a couple of things with regard to Autodesk's sort of logic in going this track. For a number of years now, we've been talking about the future of making things. And we talk about this quite often because it's not really about how things are going to be produced in the future, but it's really how things are being produced today. How can we get our product to market quicker? And how can we make our manufacturing systems more integrated? And I guess at the end of the day, generate a more lean manufacturing system that obviously is better for everybody. We can't continue wasting so much of our product. We have limited resources, obviously, with our planet under huge pressure at the moment, but obviously trying to turn that around in the manufacturing sector to make things with less waste. And really that's what Industry 4.0 is about as well, is about generating things in a more lean fashion. So we're going to be talking a little bit about some of the Autodesk tools that help us to collaborate better, to connect better, how we can innovate in a more appropriate fashion, how we can automate things and use greater sensing devices and things like that to reveal real-time patterns of our production environment. So we see lots and lots of demands on current resources. And as I said before, really, we can't keep making things the way we are at the moment. I've seen a number of stats about for things like spare parts for the automotive industry, only 70-something% of those parts ever go into actual use. The bulk of them get scrapped. So really, we need to be working smarter, and we need to work in a more interconnected fashion. And I think over the past few months, with the challenges of the global pandemic, COVID, you'll agree that things have become much more connected. And well, I guess we have to physically be disconnected, but the benefit is that I guess we've been able to work in an environment with cloud sharing and things like that that have made that perhaps work in a more seamless fashion for us. So really, at the end of the day, a lot of what we're going to be talking about today is making things more efficient. How can we generate more components from less product, and how can we innovate in a more improved fashion so as we can work with the resources that we have at hand and not consume any further resources. So obviously we need to change the way that we do business. We need to change the way we manufacture things. And we've seen this change over the years. There's been a number of elements of manufacturing that have taken that up. For instance, 20 odd years ago when I was doing my apprenticeship, CNC machines were pretty rare, but nowadays every machine shop should have CNC machines, and we can certainly make things in a much more efficient and methodical way using some of those CNC control systems. But we hear from our customers frequently that they're looking for ways to innovate. But trying to find the time to innovate is not an easy thing to do. So all the consumers out there are looking for better ways, better performance, and obviously a complete understanding of how our designs operate before we think about going ahead and building any of those components. So I'm sure we've all come across the term Internet of Things, obviously with Google devices and things like that, and being able to switch various control systems, and even the lights at home now can be switched on and off with a smartphone. We can activate our doorbell often from a smartphone. So lots of different things that are working towards that, and using the Internet of Things, or what's often referred to as IoT, we can have some interaction with those elements. But obviously those devices are becoming more available. Obviously, as time goes on, they become cheaper and cheaper to manufacture. And so those sensing systems, like I mentioned earlier, for instance, in the automotive industry, modern cars often have braking sensors and lane detection sensors to make things safer. But we're going to see a lot of that sort of technology entering into other aspects of our lives, and moving forward, we'll be seeing a lot more sensory devices added to different activities that we use day by day. So let's just talk a little bit about the history of where Industry 4.0 comes from, and I won't bore you too much with this. I know nobody likes to talk about the family tree, but and we certainly won't be doing that. But I find this a little bit interesting. And this particular image was from a presentation that was done by RMIT some time back. And basically over the course of recent modern history, you might call it, since the late 1700s, early 1800s, we've seen effectively 4 industrial revolutions. The first one was with mechanical production, and people were starting to use machines and systems to make and manufacture components easier. In actual fact, funnily enough, the first of those systems was the weaving loom. And you might say that's been around for a lot longer than that. Well, yes, it has, but obviously they went into much greater production in the early 1800s, late 1700s. So that was Industry 1, if you like. That was the first industrial revolution as such. Industry 2 came about in the mid-late 1800s with the first assembly lines and mass production. Things like electricity were all discovered in that era, and production of oil and petrols and diesels and things like that. So we now have engines running on different fuels other than just water, or steam engines, as we had previous to that time. Industry 3 is an interesting one as well. So this one was much closer to our day. In the late 1960s, there was the third industrial revolution, as they call it. And again, that revolution began to, we saw changes there that incorporated more electronics. And like I said, with CNC machines and computer-controlled systems, and even CAD systems really came about as a result of the third industrial revolution. So I guess the progress of personal computers and microprocessors and things like that, we've seen quite a change since the 70s in the way that things are made. So we've gone away from manual type systems and moved into more automated systems with that. So the fourth industrial revolution is what we're referring to when we talk about Industry 4.0. And really it's only in the past decade or so that we've seen this industrial revolution emerging. And there's quite a few people excited about what's going on with this particular revolution. Obviously, moving now into a system where we get real-time sensing. And like I said before, the Internet of Things has caused us to rethink how we share data, particularly CAD data. We're interested in the manufacturing or industrial world. But we're seeing a lot of introduction of what we call cyber physical systems. And we're seeing a lot more interlinked and connected systems that control the way we manufacture things. So we're talking about digital revolution, I guess, in that sense. But a real big part of this, like I said, is sharing data amongst multiple people, whether it be within your business or perhaps a vendor or a client. We need to share that data across a system. And obviously, as you can imagine, back in the 80s and 90s, and even into 2000, when we didn't have the internet speed that we have now, obviously sharing that data was a challenge. But now with greater internet connection and the sharing of data and large amounts of data is actually quite a big change and changing the way that we really manufacture and create components. So with regard to Industry 4.0, there's obviously quite a lot of different terminologies out there, and you'll probably come across these as time goes on, but some of you may be aware of them already. But there's actually, whilst we've got the Internet of Things, there's also another acronym called the Industrial Internet of Things. So using sensing systems within industry to create smoother workflows and better situations that allow us to create and manufacture things in a more connected fashion. So there's just a couple of things there with regard to Industry 4.0. Like I said, some big changes in the way that we communicate with each other. Obviously, with communications now being much more interconnected, things like various other elements of our communication systems, which are now enabling us to communicate particular aspects of business within a much more closed system. So you can see there I've listed some of the main points around Industry 4.0. So up in the top right there, you've got VR and AR, so virtual reality and augmented reality. And that's a very big subject that we won't be going into in huge detail today, but artificial intelligence, so systems that learn from certain patterns of data that respond and then feed that back to a main system that then processes reports and things like that that are generated based on that. So lots of different options, and really the ones that we're going to be talking or focusing mainly are the to the left there of that image, the cloud computing side of things. Obviously, we've talked about automation, but we're talking about far greater automation in the future. Advanced manufacturing comes down to, again, just quicker systems and feedback systems that tell us, that enable us to respond in a much more proficient way. Like I mentioned before, smart sensors now with autonomous vehicles and things like that, and vehicles that are able to appreciate what's going on around them, to know when to brake and to move forward and to move clear of another obstacle or whatever it might be. So quite a lot of changes going on in our manufacturing world because of what's going on with each of these aspects. So really, in short, just to summarise Industry 4.0, it really comes down to three major things, in my opinion, that are really going to change the way we work. And I guess when we're talking about Industry 4.0 in relationship to manufacturing or industry, really it's about becoming more interconnected. Like I said, whether it's interconnected with your colleagues, maybe on the other side of the world, maybe with a vendor or a client, also maybe located in a different country. So really one of the key elements of Industry 4.0 is being more interconnected with those systems. We also talk about sharing data more quickly and more freely for a multitude of reasons. So this, I guess, is the second point that I've listed here, that really data is analysed at the point of source. So as the data is generated, like I said, from maybe a lane sensing camera on your motor vehicle, it obviously that data is analysed much more quickly, and we can assess information from that. And I guess the last big point from a manufacturing perspective is that we can respond more quickly to the way market changes and the different responses that how we react to those changes in market trends or in the way things need to be manufactured according to certain demands and systems of that nature. Certainly Industry 4.0 is a much bigger subject than that, and look, we could spend many hours talking about it today. Obviously, the people that are in the virtual reality and the augmented reality talk about things like digital twins and aspects like that. But like I said, we won't be going into that level of detail today. We'd need a good number of hours to run through all those details. But really what I want to do today, like I said before, is present some of the amazing tools that Autodesk have generated to help us and to, I guess, help end users of their software to link with some of these technologies and to really be able to keep up with the requirements of our ever-changing digital age. And really it was that logic that spawned the creation of things like Fusion 360. So I'm going to talk a little bit about Fusion 360 in a moment. Fusion 360 is effectively a CAD system that Autodesk have generated, and we're able to use it in a very interconnected way, so we can share data over the cloud and get real-time updates as to how our design or whatever it might be is progressing along a certain path. Now, Fusion 360 is just one of these products. Autodesk has a pile of products, really, or a stack of products that are available that all make use of cloud services. And I'll go through those in a minute. But like I said, this all started out around about 10 years ago when Autodesk released their version of a data storage system in the cloud, which was called A360 or Autodesk 360 it was originally called. And basically from there, there's been a whole bunch of other tools. So A360 is effectively, for those of you that might be aware of Dropbox or Google Share Drive or any of those tools, effectively A360 is Autodesk's version of a data sharing cloud service. So as time's gone on, more and more people have taken up some of those products and are using them now. So you might have heard of Fusion Teams, for instance, or BIM 360 Docs, which is a similar product but for the architectural industry. And A2K frequently do webinars on BIM 360. So if you'd like more details on that, please visit our website, or I'll share a couple of links with you at the end of this presentation that will point you to those aspects of the BIM resources that are available. So I mentioned before that Autodesk have quite a plethora of products that all fall into this cloud type area. And like I said, it started off many, many years ago with A360, like I said, which was basically a cloud sharing data application. I'll be going through some of the functionality of that a little later on. I mentioned before about BIM 360 Docs as well, which is basically a work sharing environment for people that are using Revit or architectural CAD software. And also we've got Fusion Teams, where obviously, again, we can collaborate very closely with a range of other personnel within our organisation and share data with those on an as-needs basis. But there are a bunch of other tools, like I said, and on the right of that slide, I've just listed some of the main cloud tools that are available. And you'll find most of these have a 360 after them, just to indicate that that is part of the Autodesk cloud type system. And look, these systems all fit into different aspects of specific industries. So you can see there we've broken that up into 3 columns. So first up, we've got general design and collaboration. And in there, we've got the AutoCAD mobile app. So we've actually got a version of AutoCAD now that will happily run on a smartphone, for instance. So if you've got an iPhone or an Android phone, we can run a version of AutoCAD on that, or any device really, an iPad, whatever it might be. We've got Recap Pro, another pretty powerful tool that uses scan data and collaborates via that system. There's quite a bunch of tools, as you can see, for the building and construction industry, mainly connected with Revit and BIM. So you can see building infrastructure modelling is listed quite a lot there, but quite a number of other tools. Towards the middle of the second column there, we've got some for the product design manufacturing areas. And like I said, we've got Fusion Teams, Fusion Lifecycle and Configurator. And also up on the top right there, Fusion 360, which is the one that we're going to do a little bit of a demonstration on later on. We've also got a couple of others there on the right. We've got rendering in the cloud, so we can send a render process, if you like, from some of the Autodesk software systems up to the cloud, and basically that render gets done roughly in 1/10 of the time. So effectively, a 10-hour render on your local PC would be done within an hour. Again, don't quote me on that, but that's what they're telling us their cloud servers are capable of doing. So we can render things much, much more quickly. And obviously that means getting the job out the door much more quickly, rather than locking up your machine for 10 hours for that particular processing to take place on your local machine. So yeah, rendering in the cloud is a very common one, again, especially in the building industry. So we want a fancy rendering of a multi-story building or something of that nature. And basically what it does, because there's large banks of servers with multiple CPUs and GPUs and stacks and stacks of RAM, obviously they process those render processes in a whole lot quicker time frame. So like I said, what I want to do today really is focus on Fusion 360. Like I said, it's one of the Autodesk tools that is connected to their cloud offerings. And I'd like to just particularly point out, and look, we're not going to be spending any real time going through the whys and wherefores of Fusion, but I will give you a quick rundown on the interface, and also just talk you through some of the various tools that are particularly cloud tools that are connected with the Fusion software. So shortly we'll switch over to a demonstration of the Fusion area, but just a couple of things about Fusion first. Basically, like I said, anything in the Autodesk suite of products that has 360 after it really connects it with a cloud type service. Okay, and Fusion is an interesting one in that we still install a local application on our PC, so it's not completely cloud dependent as such, but it is cloud enabled, which means it connects with the cloud. It automatically does its updates and things like that, and also we get a range of other tools associated because we're constantly connected to basically a cloud storage system where we can save our files into the cloud, and we can do different things, and I'll be going through that in a moment with you. Like I said, not cloud dependent in the sense that we can work offline for a period. So I think it's about 20 days we can work offline quite happily. So if you're going away and not going to have great internet connection, you can cache your local files. So you can save your local files to a local drive quite easily. And I will touch on that in a moment. So really the big benefit of cloud tools is that we can simply connect a user with a file, and the system will email them a link to see where to share that file or where to view that file. And we can also then give them different permissions. So we can say that maybe somebody in the sales department needs to be able to see the file, but perhaps we don't want them to edit it. So, however, we're going to share it with our engineering manager, who also has the opportunity to edit the file and make necessary changes before that particular product goes to the next step or goes to the market or whatever it might be. One of the other really, really powerful tools about Fusion is that it's one of the very few CAD systems that will function natively either on a Macintosh operating system or on a Windows type system. So very, very powerful in the sense that if you're a Mac user, we can use a locally installed version of Fusion on your Mac, just like we could on our Windows PC. Again, the benefit of that is that if you've got an iPad and you want to share your design with somebody, you can open the file that you've just been working on your desktop Windows machine and share the 3D image with perhaps a vendor or a client, and maybe do some redlining or markup at their site. Go back to your office and those updates are all available directly on your Windows PC. So very, very handy to be able to work with either Mac or Windows type systems. The other very powerful thing about Fusion is that it's a surfacing tool as well. So we've got the option to work with T-splines and NURBS surfaces for anybody that's involved in those industries. But yeah, so let's jump into Fusion. What I thought we'd do now is just a quick demonstration, and I just want to run through a couple of things about Fusion. Like I said, give you a brief rundown, particularly, I suppose, of some of those elements that make it connected with the cloud as such. So here's my Fusion screen. You can see there, hopefully, just perhaps to confirm there, Dexter, you can see my Fusion window okay? Assume we can all see that all right. Anyway, I'll jump into the demonstration of Fusion. So this is the Fusion interface. It's quite a simple looking CAD system. Up in the top left here, we've got 6 or 7 different areas of Fusion, if you like. We've got the design area where we can obviously create mechanical designs. We've got an area called Generative Design, and we're not going to go into this one in huge detail today, but it is a very interesting, actually I might pop a few slides in at the end on this particular tool, but basically what Generative Design does, again, it uses a bunch of supercomputers effectively to redesign your part dependent on certain parameters that you input. So if you were to tell, as in the example of the little caster there, that this caster is going to take 40 kilograms or whatever it might be of load, and that this is the connection point, this is the bearings, etc. You can see what we would generally model from a fairly simplistic point of view would be the model on the left. On the right is a computation example of what that could look like if we were going down a track of 3D printing or additive manufacturing process. So I'll go through that in a little bit more detail later on. So Fusion has a rendering environment where we can set up lighting styles, and it does a very good job, as you can see there, of doing renders with quite nice, realistic edges to them. We can animate assembly, so we can show an assembly in its exploded form for maybe a service manual or assembly instructions. So we've basically got like a little video producer in there where we work with our assembly to show it in its exploded form. We've got a simulation environment, and again, this is very much a cloud tool within Fusion, where effectively we can, as per the example there, we've got a set of bicycle forks, and maybe we've put 40 kilos of load or 50 kilos of load on the where the axle would run through the bottom of those forks, and then we can stress that. and simulate the stress and show us how the particular fork system is going to behave there with that particular load. CAM is another big area of Fusion. So CAM, or manufacturing environment, where we can go in and set up some tool pathing. I'll take you through a little example of that later on, where we can actually go in and simulate and create tool paths for CNC manufacturing of our particular components. And lastly, over here, we've got the option to create 2D drawings. Now, 2D drawings in our world are actually playing far less and less of a role, in the sense that very good to give somebody an example of a 2D file, but if we can give them a full 3D model and then have them take their dimensions and sizes from that 3D model, which has been machined from that same tool using the manufacturing process, obviously we've got a very interconnected system. Okay, so we've got a range of different options here. Basically, as far as a CAD tool goes though, the Fusion interface is fairly traditional. It's a fairly typical type interface. Where we've got standard tools for extruding and creating different solid shapes, menus with different options in them here, lots and lots of different methods of creating different items. But the really important part of Fusion is this little icon up in the very top left, this what the Americans call a waffle, I believe, but it's 9 little boxes up in the top left here, this little icon here. When you click on that, it takes you to what's called the data panel. Okay, so the data panel is effectively like my storage area in the cloud where all of my files are stored. So this works a little bit like your C drive, if you like, but again, accessible from any system. So if you would like to give your particular user access to one of your projects, we can right-click on this and we can do a number of things here. I'll go through some of these options later on. But effectively, we can share and go into this project, for instance, and I could go in here and share a public link or share this with another person within my organisation. So quite a few different options with regard to how we can work with these files. The other really clever thing that this does as well, it keeps versions. So this little option down in the bottom right of this Clevis file, for instance, is telling me that I created a file back on the yesterday at about 2:52, and then I did a save of that at 4:53 yesterday afternoon. And Fusion will keep that history. Okay. Not only that, it tells me where it's been used. So if I put this Clevis into an assembly, it would tell me that it's connected to a particular assembly within my situation of my Fusion scenario there. So the version control system, which is all managed within the cloud, is quite a handy system as well. All right, so yeah, very, very valuable that these files here I can share with other people. As you can see up here, I'm the owner of this particular project at this point in time. But like I said, we can invite other people to have access to this project and collaborate with them in real time. So the benefit being that we can very quickly go in and share these files over the internet, and anybody else can look at them. Like I said, I can give, there's different permissions I can control over that as well, with regard to sharing files or working with different aspects of how my Fusion model might work. So one or two things that I just wanted to quickly show you about Fusion in the sense of it being a cloud-connected tool. If I go into the render environment, for instance, and select the option to render here, you'll notice I've got two options. I can render with the cloud renderer, or I can use my local GPU and CPU to render this image. Okay. Now down here, I've got an interesting part of Fusion where it's telling me that if I do this render, it wants to consume 1 cloud credit. Now Autodesk sell cloud credits. They're about $1.60 each or something per credit. But when you think about what that's going to save you in time, as you can see here, it's going to take 20 minutes to render this image. But like I said, it would take roughly 10 times that long if I was to do it on my local local PC. In fact, I think it will tell me in here. No, it doesn't. I thought it would tell me a time roughly to do the local render. But basically what this will do, if I was to click render here, it would charge me $1.65, and then it would go off, and 20 minutes later it would come back with this image in a nicely rendered format, which yeah, comes out quite nice. So yeah, lots of different options with regard to the way, so you can see there the rendering process happening. So this will just be doing a very brief review, a preview, if you like, of how this render is going to come out. Yeah, this is just a quick GPU, and I have got a fairly hefty laptop that I'm working on at the moment, so it's going to do that fairly quickly. But, as you can see, the granular faces here will eventually disappear, and that will go through. So, like I said, that's one of the big differences, and this is one of the cloud tools that Autodesk have provided within Fusion to enable us to do that. Now, we get the same under the simulation environment, where we can run like an FEA study. But again, if I run a study and do a stress type system using one of these particular tools here, so you'll notice there's quite a few different stress studies we can do. We can do structural buckling, we can do thermal stress analysis, event simulation for impact, quite a few different types of stress studies we can do. But again, we can use a Autodesk server to generate this a lot quicker, and to actually create that study in a much quicker fashion. So yeah, like I said, if we wanted to put 10 kilos of load onto the blade here and see how it affected the internal workings of our utility knife, as it's called, or our Stanley knife. Stanley's a brand, so we're perhaps not allowed to say that, but yeah, so basically we can use the Fusion tools to do some of those studies for us. So yeah, quite a number of these tools will use various elements from the cloud. One other interesting one is if I export a file, and Autodesk are just changing this process now, but if I was to go in here and export this, often it will use a cloud service to export the file into some of these other formats. So you'll notice I can export out as a STEP file, a SAT file, an IGES file. Some of these it does via a cloud server. Not that it will charge you at this point, but effectively it will export that using a cloud service to generate the exported file. So one of the other little tools that I just wanted to quickly give you a run through on was this one here, a little CAM simulation. So obviously, as you can see, we're machining this little, looks like some sort of a end cap for a hydraulic piston or something. We've got that sitting in a vise there, and basically within Fusion, we've got this really nice little manufacturing interface where we can go in and set up for a specific machine. So we can go in and tell Fusion which machine we're going to be creating this particular part on, and it comes up with this machine library where I can pick from a range of different libraries. So in here we've got a whole range of different machines that we could be creating this particular part on. And then basically once we've done that, and I've gone through this process previously, and I created some toolpath in here. So we set up facing operations, contouring operations, pocketing operations. But the really cool thing is we can simulate this in real time. So when I jump into this simulation environment, now this is done locally. This isn't a cloud service so much, but basically now I can watch my toolpath as we create that particular component. So you can see where we go in and machine that. We've got all sorts of little controls here to speed this up or slow it down. But so yeah, basically within the CAM section or the manufacture section of Fusion, we can go through and watch our particular block, whatever it might be that we're machining, be created. And then we can export that out as what we commonly refer to as G code. And that goes off to our CNC machine, and we can generate that particular component. So it's just another little example of how we might machine something in the Fusion interface. So that one is a local simulation process, but there certainly are other CAM systems that would allow you to do that in the cloud. So we can do all sorts of different things in here with doing probing. So we can go in and sense, for instance, the diameter of this hole and do analysis on that particular function as well as we work through our Fusion environment. Okay, so one other little area that I thought I'd just quickly talk about. So this is a very simple 3D part. And I mentioned before about generative design. So, and I won't run one of these at this point because it will probably bomb my Zoom session out. But effectively what we can do with this particular component is we can simulate, so we can set up some particular areas. So we can say that we want to bolt this particular part down with these 4 holes here. So I would preserve these regions, these 4 hold down holes. I would also preserve the internal bore here where I've perhaps got my clevis attached or my hydraulic cylinder attached. And then we would set up with this one here some obstacle areas. So maybe we need to be able to rotate the hydraulic cylinder through 180 or 90 degrees or whatever it might be. So we would need to make sure that we can swing the hydraulic cylinder right over. So we might create this as an obstacle geometry. And then effectively we run the design study. So we can go through a process over here and generate the design study, which will then tell me that I can save X amount of material. And I've actually done this as a previous study and run through that. So, but like I said, if I run this now, I think it will probably cause my Zoom session to stall. So I won't go through that at this point, but effectively we set up the material type we're using. So if we're making this out of a high alloy steel or something of that nature, we can run that particular study. So effectively what we can do then is go through a process, and this is what it will look like. So what Fusion does, it will generate, using the CPU or the cloud service, and it will generate some suggested model shapes that we might like to consider for replicating that particular clevis. So like I said, where something that we might have designed some years ago would look like the part on the left, we can go in and generate the part at the center there, which is going to be, and I told it that I wanted it to be reduce the weight by 30%, and that I wanted it to retain its strength to plus 10%. So I want a setting of such and such to ensure that I've still got the same strength ratio. And then in actual fact, we printed that part on the right on our Markforged Melex printer, which we've got set up out at Parafield here in Adelaide. So yeah, we've actually been down this path and done some studies, and yeah, quite an interesting sort of process for being able to take that sort of what might look like a fairly clunky part that maybe looks like it came from the 1980s through into a computer generated model that we can then do. So sorry, what I told it, I wanted it to be a 40% weight reduction, and it did that. So it actually went, this part on the left weighed originally 1.5 kilos, and I think we managed to cut that down by 640 grams. So it was just under a kilo when we finished in production, and that was ready to go. Now you might look at that and say, yeah, but I'm not going to machine that on a CNC machine. No, that's true. But really, what we're finding now is many more people are considering 3D printing components, given that we can print now in tool steel, we can print in Inconel, we can 3D print in copper, and a range of other materials. So a couple of grades of stainless steel as well. So yeah, quite a powerful tool to think about using moving forward. So I guess in that sense, we're making things with far less waste and lighter. Obviously, this technology is being used for some time in the aerospace industries, but more and more now we're finding this moving into automotive type industries and so on and so forth down the process. So here's another little example of a component that was generated using what we call generative design. So this is actually a General Motors part. It's the mounting bracket for a seatbelt system in one of their vehicles. As you can see on the left, there's numerous metal pressings. Parts went through multiple folding operations, and it was made out of a total of 8 components initially. But putting it through a generative design system, they were able to create it 40% lighter, but 20% stronger. So you can see the obvious benefits here of being able to 3D print that part now based on a computer-generated model. So effectively, with Fusion and many of the other CAD tools available today, we've got these generative design tools. Now, what that did, it gave us a number of different options we could choose from. So there's a dozen or so of the items that we were able to select from. We could go in and pick any one of those, and they'll all have different benefits, whether it be greater stiffness but we can certainly put that into our design study.